3 years ago, SpaceX undertook a gigantic construction project. In Boca Chica, Texas, hundreds of people are working tirelessly on the world's largest launcher, the Starship. Elon Musk, the controversial chairman of SpaceX, has announced it. Thanks to this rocket, we're going to colonize Mars. What's up, Polly? You think it's all rubbish? Well, let's find out. On December 2015, SpaceX successfully landed the first stage of its Falcon 9. With this achievement, the Californian manufacturer aims to reduce the cost of access to space by reusing its launchers. But this particular design is only the first step towards lowering costs of access to space. The company that has shaken up the space industry has already taken the next step: a fully reusable super launcher capable of delivering over 200 tons into low Earth orbit. Why? Well, Polly, let's say that the price per kilo sent into space is directly impacted by the rocket size. The heavier the launcher, the greater its payload to total mass ratio is. The payload is what you want to send into space, like a satellite. And the total mass is the weight of the launcher, the payload, and its propellants at liftoff. For instance, with Rocket Lab's Electron rocket, for 1 kilogram of payload, we need around 56 kg of total mass. With a launcher like the Falcon 9, this ratio improves to 24 kg, and for the Saturn V that took men on the moon, we're down to 22 kg. Results may vary, of course, according to the technologies employed and the targeted orbits, but this ratio gives a clear economic lead to large launchers. However, whatever the size, rockets are incredibly complex and expensive machines, from a few tens of millions of dollars to several hundreds, and at the end of a journey, we throw them away. Imagine, Polly, if we did the same thing when you get on a plane. The price of your ticket would be much higher. SpaceX's challenge is it's to be able to recover its launcher for reuse and, once again, cut costs. A technology they've been mastering since 2015 with the first stage of the Falcon 9. Since then, they've managed to return them to flight condition at reduced cost more than a dozen times. Little is known about the actual cost of maintaining these boosters, but the prices charged by the Californian company and their rapid return to flight condition seem to confirm this gamble. Finally, by increasing payload capacity, SpaceX could carry out a wide range of missions, from commercial missions sending large satellites to putting space station into orbit in a single shot, or missions exploring our solar system, such as the HLS contract with NASA to develop a lunar lander. Today, it's hard to imagine what we could achieve with such a large payload. The Starship market doesn't exist yet, so we're mainly going to remember that it's a new launcher that's more versatile and cheaper than the Falcon 9 and all the other rockets in the world. Here it is, Polly. The Starship is SpaceX's solution for lowering the cost of access to space. However, it remains to be seen how they're going to do it and if it's going to work. Welcome to Boca Chica in Texas. Polly, you better put your helmet on. This is where SpaceX is building the Starbase. A gigantic launch base that is also an open-air factory for a radically new spaceship, the Starship. Well, how can we build a super launcher entirely reusable? It features a first stage called the Super Heavy, 69 meters high, 9 meters in diameter, with a takeoff mass of 3,600 tons. As always, with the aim of reducing costs, the engineers opted for a stainless steel structure. This offers several advantages. It's a cheap material, which means many iterations can be carried out. Moreover, steel retains its mechanical properties of a wide temperature range and acts as both structure and tank. At its base, it houses 33 Raptor engines, SpaceX's new closed-cycle rocket engine, which deserves a video of its own. On top of the first stage is the Starship. The launcher's second stage is 50 meters high, 9 meters in diameter, and 1,200 tons at liftoff. It is also made of steel, but has a thermal tile covering, just like on the American Space Shuttle, and winglets to control its atmospheric re-entry. It uses the same engine as the first stage, the Raptor. I hope you strapped in, Polly. We're taking off. The Starship and the Super Heavy are assembled on the launch pad using the launch tower. The first phase of flight involves the ignition of the booster 33 Raptor engines. At this precise moment, they produce a thrust of 76 meganewtons, propelling the launcher into the air. The arm supplying fuel to the rocket detaches, and the Starship leaves the launch pad. After 2 minutes of flight, at an altitude of around 60 kilometers, the Starship separates from the booster and ignites its own engine. The first stage begins its return maneuver in the same way as the Falcon 9. Upon arrival at the launch pad, it ignites its engines one last time and is grabbed by the chopsticks that are metal arms attached to the launch tower. The Starship on its side carries out its mission, whether it's refueling with propellant, a mission to the moon, or a return to Earth. In the latter case, thermal tiles protect the craft during the atmospheric re-entry, and it uses its 4 flaps to steer itself. A few hundred meters above the ground, the Starship pulls up for landing with a maneuver called belly flop and lands gently with just one engine. You still think it's all nonsense, Polly? Well, just look at what's already been done. In just a few years, Boca Chica has been turned into a true space hub to the despair of its inhabitants. A few evictions for Elon Musk humanist project, which will enable him to colonize Mars. Gigantic semi-permanent tents and hangars dozens of meters high are used to build and assemble the starships and their boosters. A propellant farm stores the oxygen and the methane needed to fill the rocket, and since 2021, a 122 meters high tower has enhanced the launch pad and should enable the booster and the Starship to be recovered. The Starbase is mass producing its rockets, Starhopper, Mk1, Mk2, SN1 up to S25. It's hard to keep track of a number of test articles and spaceships built by SpaceX. Teams are able to carry out pressurization tests and suborbital flights with some of these prototypes. This led to some spectacular and controlled rapid disassembly. And the next step is pretty clear: a successful orbital flight. The very least thing we can say is that the success of an orbital launch is key for SpaceX and the development of its Starship. It will prove a concept on which the Californian company has been working for almost 10 years: a fully reusable launcher. Of course, Polly, numerous failures are to be expected at every stage of a flight, as demonstrated by the most recent loss of a launcher 3 minutes after liftoff. Even before takeoff, the flight plan has to be validated with the FAA, the US government aviation agency. Then, a problem with the engines could lead to the destruction of a Starship and its launch pad. Once in flight, the stage separation must happen, the Starship's engine must ignite, and the booster must return to Earth without destroying the launch tower. As for the Starship, it will have to successfully enter orbit, perform a few maneuvers into space, then return to Earth safely and withstand the atmospheric re-entry. A challenge that's still very hard to predict. And yes, Polly, it is not a given. And finally, it will have to make a successful landing without losing the ship. Well, finally, let me remind you, Polly, that the aim of Starship is reuse, to cut launch costs even more. It's all for nothing if the SpaceX teams cannot get the launcher to fly again. And now, Polly, the billion-dollar question. Will the Starship change the world? I would rather warn you, we're entering the realm of speculation, and let's be clear. No one, absolutely no one, not even SpaceX or any space expert, no one can claim to have that answer. Nor can you, Polly. However, we can say two things. First of all, to fulfill this ambition, SpaceX needs to validate its concept. In other words, not only a successful orbital launch, but also proof that the Starship is indeed a low-cost, fully reusable rocket. The design choices are bold and look promising, but only repeated testing will validate them. It's even highly likely that some of the objectives will be scaled back, and that's just as good, because SpaceX's strength lies precisely in its adaptability and rapid iterations. The Starship will certainly see the light of day, but its final version will undoubtedly be very different from the prototypes that exist today. The second assumption is that the Starship won't be able to handle every mission. Even if SpaceX promises to drastically reduce the cost of access to space, the destination will still be very expensive and dangerous. Firstly, because what probe and satellite operators are looking for is not only low-cost access to space, but also specific orbits. There's no point in launching for practically nothing if you're going to end up in the wrong place. And the same goes for manned flight. Reliability and reduced risk of loss of a vehicle are far more important than the seat cost. Without ejection systems, takeoff, atmospheric re-entry, and landing represent too great of a risk for passengers. Future manned missions of a Starship will undoubtedly be carried out by the Crew Dragon, which will serve as a shuttle between Earth and space. Finally, to operate, the Starship needs to be refueled more than a dozen of times into orbit, an operation that can quickly become a constraint for several missions. The Starship promises to be a fantastic cargo ship for reducing the cost of access to space. A super launcher that could launch a small space station in a single shot. A still uncertain market for a rocket that has yet to prove itself. But one thing is certain, we have entered the era of the space economy and the space industry. And if there's one launcher that can take the cake, it's the SpaceX Starship. The challenges ahead of the Starship echo to the space race back in the 60s, when the USSR and the USA tried to be the first nations to reach orbit. This challenge was met, not without difficulty, thanks to an equally astonishing launcher. To find out all about this fascinating story, take a look at my previous video on the rocket that shook the USA, the Soviet R-7.